Manage capacity for Azure NetApp Files using Azure Portal. You can change the size of the volume as necessary from the Azure portal. A volume's capacity consumption counts against its pool's provisioned capacity. Let's resize a volume from Azure NetApp Files. Under Storage Service, select Volumes. Right-click the name of the volume that you want to resize. Select Resize from the top menu. In the Update Volume Quota tab, change the quota size to the desired value. Click OK. After successfully updating volume quota, you can verify the new size of the volume. However, in some cases, the hosting capacity pool does not have sufficient capacity to resize the volumes. In such cases, you can change the capacity pool size in 1 TB increments or decrements. Select the capacity pool and select Resize. In the Resize Pool tab, enter the new capacity pool size as required and click OK. Resizing the capacity pool changes the purchased Azure NetApp Files capacity. After successfully realizing the capacity pool, you can verify the new size of the pool. You use the context menu options to resize or delete the capacity pool. Azure NetApp Files metrics are natively integrated into Azure Monitor. From within the Azure portal, you can find metrics for Azure NetApp Files capacity pools and volumes from 2 different locations. In the Azure NetApp Files portal, search for Monitor. From Azure Monitor, select Metrics and select a capacity pool or volume that you want to access the metric of. Then select Metric to view the available metrics. Another place you can access the metrics is from the Azure NetApp Files capacity pool or volumes. In this example, let's access metrics for a volume. You need to select a volume and select Metrics under Monitoring from the left pane. Then you can select Metric dropdown and view the available metrics. In Azure NetApp Files, the files are represented by blocks on the underlying file system. Files consist of metadata and data blocks written to a volume. Each represented block points to a location on disk where the block contents are stored. In this example, there are 3 files, each consisting of 3 blocks, File 1, File 2, and File 3. When a snapshot 1 is taken, it copies the metadata and only the pointers to the blocks that represent the files. The efficiency of a snapshot is in the fact that a snapshot copies the pointers, which effectively creates a view of the file system at the time the snapshot was taken. Future changes to the file system do not affect snapshots, and the blocks referenced in the snapshot are kept unchanged for as long as any pointers reference them. It is only after no more pointers reference a block that the block is freed up for reuse. Let's say the files on the volume continue to change and new files, File 4 in this case, are added. Note that changes to existing files are stored on new empty locations in order not to change the existing blocks, since those are referenced in 1 or more snapshots. A new snapshot, Snapshot 2, is taken to capture the new changes and additions. The previous snapshot, or snapshots, remain unchanged and unaffected by the new snapshot. When a snapshot is taken, the pointers to the data blocks are copied. The snapshot pointers continue to point to the original data blocks that the file occupied when the snapshot was taken, providing both live and historical views of the data. If you were to create a new snapshot, the current pointers are copied to a new snapshot. Note that each volume supports up to 255 snapshots. Azure NetApp Files snapshots allow near-instantaneous, secure, and optionally user-managed restores. This video describes how data can be accessed or restored from Azure NetApp Files snapshots. A snapshot can be restored to a new volume, which creates a new independent volume in the state the source volume was in when the selected snapshot was taken. This leaves the source volume unchanged and allows for the restored volume to be used for individual file restores, by drag and drop to the source volume, or to feed current data to test or dev environments. You can restore a single file in place from a snapshot. Consider file 2 in this example, which only reverts the pointers to existing blocks previously captured in a snapshot. This eliminates copying any data blocks and is near instantaneous irrespective of the size of the file, that is, number of blocks in the file. You can also restore a different version of a file by relocating it to a different folder or by renaming it file 2.